Greetings, ladies and gentlemen. In this video, we will be talking about infinite series. Now, this is just an introduction to infinite series because I first wanted to go over all of the types of series that we have and test for convergence and divergence. All right. Now, what is convergence and what is divergence? Well, convergence is when the series comes out to be a single number, whereas divergence is when it comes out to be positive or negative infinity. Okay. What do I mean when it comes out to be? Well, the result of these tests. And in the following videos, we will be going over more information about these individual series and more about these tests to see if these series converge or diverge. Right now, I'd just like to go over what an infinite series looks like and why is it different from just a regular series. If you haven't worked with series before, let us know and we'll create a video answering just that type of question. So, excuse me. Infinite series looks like this letter here is representative of a summation, right? Summation of 1 over 2 to the n, and this is just an example where n equals 1 goes to infinity. Now this is an infinite series. This is infinite because this series goes on to infinity. Essentially what happens is that you start off from this index term, this is called an index, and substitute this n for n. And once you substitute it for n, now then you add that term with the term where n equals 2, n equals 3, and so on and so forth, all the way up to infinity. A finite series has a specific number where the sum ends. This one is infinity. So therefore it is infinite. So when I was talking about these indices, let me go into a little bit more information regarding that. Essentially what would happen is we would come here and write 1 over 2, and for n equals 1, substitute the 1 directly into there. So we'd have 1 over 2 to the 1 plus 1 over 2, well, the next index value. Well, after n equals 1, it would have to be n equals 2 plus 1 over 2 to the, well, this is n equals 1, 2, this should be n equals 3 plus, n equals 4, 5, all the way up to infinity, okay? And a lot of times we have a way of finding out what the final sum is. Let's just simplify this a little bit. We have a half plus 1 over 2 squared is simply a fourth, plus 1 over 2 cubed is an eighth, plus, and this series essentially keeps on going forward, keeps on continuing. Okay, now just some basic terminology for sequences and series. When we say we have this n term, right? But throughout the videos, I will be talking about an n plus 1 or an n minus 1 term even, or even an n plus 2. Now, what does that mean? Well, I will write it in a different colored ink. N is basically this index that we were talking about, okay? And I will just put that as I. N plus 1 is essentially equal to I plus 1. Now, this looks a little bit confusing, but all that's really happening here is that if I go to the next, I plus 1 is essentially the next index or the next value, okay? Now, if the original value is 1, then the next value will be 2. And essentially, n plus 1 means plug in the next value into the sequence. For example, if I do, and I will do this right here, the same series, 1 over 2 to the n is equal to 1 over 2 to the, well, n is equal to 1, right? Okay, good. 1 over 2 to the n plus 1 now. Now, what is that equal to? Well, if n is equal to 1, then n plus 1 would simply be equal to 2, 1 over 2 squared, which is a fourth. Now, this is a fourth. Essentially, going back, n plus 1 means the next term in the series. Okay, All right, so that's basic terminology for that one so far. Last but not least, when I get to the roots, or not particularly roots, the ratio test, I will be talking about factorials. And I'll be saying n factorial, n plus 1 factorial, n plus 5 factorial. Now, factorials, okay, I'll explain it a little bit when we get to that point, but if you haven't had any introduction to what a factorial is, it's perhaps a good idea to let us know, to make a video explaining just that. I will just show what a factorial actually looks like. When I say factorial, n factorial, well, this sign here, the exclamation mark, is the factorial symbol, okay? Now if I say 5 factorial, what this basically means is take 5 and multiply with every single number that comes after it all the way until you get down to 1. So similarly, if I say 3 factorial, this would be equal to 3 times 2 times 1, okay? And essentially when you multiply these numbers together, you'll get up what their factorial is equal to, all right? But I will be talking about factorials in terms of variable terms, so please let me know if you have any questions. Now that we've covered just the basics of what these series are, essentially some types of terminology, let's get into the actual series. We have a geometric series, okay? Now, the geometric series goes with a geometric series test that we can use specifically for the series, which tells us if this series converges or diverges. The next one is a p-series, and actually I didn't write it earlier, but the p-series also contains a type of series that we use so much in our real-world applications that we call it the harmonic series, okay? Next one is alternating series. Alternating series, basically the sign oscillates. Whereas the first term, we have essentially terms over here. The first term can be positive, second one could be negative, and so on and so forth. And positive, negative, so the sign oscillates, okay? A power series is a little bit different from all of these because in series, we generally use n as our term. In functions, we usually use x. Power series actually does use an x, all right? And we'll explain exactly how that works. The Maclaurin and Taylor series, or the Maclaurin and Taylor polynomials, all right? Now, these are actually really cool because there are a lot of applications in the real world to these, and we'll get a little bit more in depth with them. Now, the test for convergence and divergence. The first one is the nth term test. Nth term test, always remember throughout the videos, this should be your first go-to test, okay? All of these tests are can be a little bit more tedious than the nth term test for divergence, okay? In fact, I will write that, I will edit that right here. This is called the nth term test for divergence, all right? Geometric series test, like I said, works with that. Geometric series. The p-series test works with the harmonic and the p-series. Integral test is a general test that can work for most of these, given some conditions. Comparison test, again, it's a general test, given some conditions. And the comparison test, there are actually two types, the direct and the limit comparison. Alternating series, or the Leibniz test, works best with the alternating series, given some conditions. The roots and the ratio test, usually we speak about them together because their conditions are the same about their answers. And ratio test is actually a great resource to use whenever you have any powers, any n powers, or if you have any factorial notations with n, okay? Now, last but not least, just wanted to go over one more thing. When we talk about functions, we talk about it in terms of f of x, essentially, right? But now that we're talking about series, well, series are generally talked about in terms of a sub n, okay? So if a function notation, if a function is something like f of x equals 1 over x. In series, we will call that a sub n is equal to 1 over n. All right? Now, a sub n, I'll just circle this, by the way, and you'll see this when we get to p in the harmonic series, that this is a harmonic series example. All right? We'll talk a little bit more when we get to that. Now, this is essentially an introduction to infinite series. If you have any questions, please let us know and we'll try our best to help you out.